Have you ever found yourself in a fit of laughter because someone tickled you? Maybe it started with a playful poke to your ribs or a light brush under your arms. But then, when you tried to tickle yourself in the exact same spot, nothing. It's like your own hands lost their magic. This isn't just a curious quirk, it's a glimpse into how astonishingly complex and protective your brain is. So why can't we tickle ourselves? Why does something so simple reveal some of the deepest mysteries of how we perceive touch, connection, and even danger? Imagine this. Your brain is a highly skilled detective, one that never sleeps, constantly predicting and analyzing every move you make. When you move your hand to touch your own skin, this mental detective already knows what's coming. It anticipates the exact pressure, timing, and direction. Because it can predict everything, your brain decides there's nothing to react to. No laughter, no surprise, just a touch like any other. This canceling effect isn't a glitch. It's an incredible function of your cerebellum, the part of your brain responsible for motor control. Think of it like this. The cerebellum is the control tower of your movements. When it detects a self-generated action, it signals to other parts of your brain, relax, this is nothing new. But here's where it gets even more fascinating. The ability to predict self-made movements isn't just about tickling, it's a survival mechanism. Imagine a scenario where every touch, every brush of your own hand or foot triggered a defensive response. You'd be exhausted in no time. By predicting your own movements, your brain saves energy for genuine surprises and threats. In fact, scientists at University College London used brain scans to show that self-generated touch doesn't activate the same neural pathways as touch from someone else. This means your brain literally processes these sensations differently. Your body knows when to react and when to keep calm. Now, if you're wondering why we're ticklish in the first place, the answer is rooted in our evolutionary history. Ticklish spots, like the soles of your feet, underarms, and sides, are some of the most sensitive areas of your body. Long ago, these areas were prime targets for threats, whether that meant bugs, predators, or even other humans. Being ticklish might have evolved as a way to make us aware of potential danger. When someone touches these sensitive spots unexpectedly, your body's response is instant, squirming, laughing, and maybe even pushing the person away. It's a protective reflex hidden behind laughter. Speaking of laughter, why do we laugh when tickled by others? It's an unusual mix of panic and joy. Scientists have found that tickling activates the hypothalamus, a part of the brain involved in the fight or flight response. This is why tickling can feel overwhelming. It's your body gearing up for something, even if that something is harmless play. But there's more. Tickling also lights up areas of the brain related to social bonding and trust. Think about it. When you let someone tickle you, it often implies a level of closeness. This is why being tickled by a stranger feels more uncomfortable than tickling among friends or family. Here's a twist you may not have seen coming. Tickling has been used in history for far more sinister purposes. In ancient China, it was reportedly employed as a form of torture. Unlike physical punishment, tickling left no visible scars. Victims would be restrained and tickled until they were physically and mentally exhausted. It's strange to think that something as innocent as a tickle can hold such dark potential, but it highlights just how powerful this seemingly simple act can be. You might be asking, could we trick our brains into feeling ticklish when we tickle ourselves? Scientists have asked the same question. Researchers from the University of Sheffield experimented with robotic arms that people controlled to tickle themselves. When there was even the slightest delay between movement and sensation, participants felt a ticklish response. By disrupting the brain's predictive model, they brought back that elusive ticklish feeling. This discovery offers a glimpse into just how finely tuned and adaptable our sensory systems are, and it doesn't stop there. The way your brain handles tickling reveals its incredible ability to differentiate between self and other. Have you ever been startled by your own reflection moving unexpectedly? Or jumped at the sound of your recorded voice? That's your brain processing unexpected stimuli. When you try to tickle yourself, your brain shuts down the response because it knows it's you. But when someone else does it, all bets are off. The surprise, the lack of control, that's what makes you laugh, squirm, and react. But let's take this a step further. Ticklishness isn't just about the physical act, it's about emotional context too. Have you noticed how your response to tickling can change depending on your mood or who is doing the tickling? When you're happy and relaxed, you might laugh uncontrollably, but if you're anxious or caught off guard, tickling might feel more irritating than fun. This is because your brain processes the sensation differently based on your emotional state. In some cases, people even experience phantom tickling sensations due to neurological disorders. These rare conditions show just how complex our brain's relationship with touch really is. To understand this even deeper, let's look at animal behavior. You might be surprised to know that some animals are ticklish too. Rats, for example, emit high-pitched giggles when tickled, a behavior discovered by neuroscientist Jaak Panksepp. This giggling isn't just noise, it's accompanied by bursts of dopamine, the feel-good chemical in their brains. Yet, like humans, rats can't tickle themselves. This suggests that the neural mechanisms behind ticklishness might be deeply rooted across species. But why does your brain bother to make these distinctions in the first place? It's all about keeping you aware of your surroundings. Your brain has to know what sensations it should pay attention to, and what it can ignore. If you couldn't tell the difference between touching yourself and being touched by someone else, you'd be at a constant disadvantage in your environment. This ability to predict, differentiate, and react appropriately is what allows us to function smoothly day to day. Now, here's a personal question. Have you ever tried to tickle yourself just to see if you could trick your brain? Maybe you moved your fingers slowly, hoping to catch yourself off guard, but no matter how hard you tried, the ticklish response just didn't come. It's a little like trying to scare yourself with a surprise jump. Your brain sees right through it. But that failed attempt to tickle yourself is more than a quirk. It's a testament to how well your brain protects and guides you. The next time you laugh uncontrollably from being tickled, remember what's really happening. Your brain is reacting to a mix of surprise, trust, and vulnerability. It's allowing you to feel that sudden joy because it knows you're safe. But when you try to create that sensation yourself, your brain steps in and says, "No need, I've got this." What does all this tell us? That your brain's primary job is to keep you balanced, safe, and in tune with your environment. Tickling may seem like a simple thing, but it's a window into just how complex and protective your brain really is. So what do you think? Has learning about the science behind tickling changed the way you see your own brain? If this deep dive into something as ordinary and extraordinary as tickling left you curious, be sure to hit subscribe and join us at Universal Insights. We're exploring the mysteries of life, the mind, and everything in between. Share this with a friend who's always tried and failed to tickle themselves and leave us a comment. Have you ever managed to trick your brain into feeling ticklish? Let's keep exploring the wonders of our own minds together.